Good morning. Let us discuss unit 2, that is bolted and welded connection. From this unit, you will have 35 marks for the exam. There may be 5 marks theory and 30 marks problem, 15 15. From bolted connection 15, welded connection 15 marks problem. There is a chance is there 10 marks theory questions and 25 marks problems. So we'll briefly explain and go. So first question is design a lap joint between two plates of 20 mm and 12 mm. There is two plates given 20 and 12 mm thickness so as to transmit a factored load of 70 kN. There is given factored load of 70 kN using M16 bolts. M16 in the sense the diameter is 16 mm of grade 4.6 and grade 410 plates. If we'll go with the given data, that is M16 bolts they given, that is diameter 16 mm and D naught is 16 plus 2, that is 18 mm. Then they given factored load of 70 kilonewton, that is PU 70 kilonewton factored load. Then thickness they given two plates 20 and 12 mm thickness, so we have to take least thickness, that is T is 12 mm. Then Fe 410, that is nothing but Fu is equal to 410 Newton per mm square. For bolts of grade 4.6 grade, then FUB is 400. If the grade is 5.6, the FUB is 500. If the grade is 4.6, FUB is 400. Then we'll go with the shear capacity of the bolt, where net area of the bolt we have to find first, that is A and B. This is needed for to calculate shear capacity, that is A and B. 0.78 pi by 4 d square, that is a formula where 0.78 is the constant value. Don't be confused, 0.78 is the constant value. 0.78 into pi by 4 d square, that is 0.78 in pi by 4, d is 16, so 16 square will get 156.82. Now we have to solve the shear capacity. For that we have to go to page number 75 of the code book. I will show the page number 75. In the page number 75 you can see that shear capacity of the bolt here. Then there will be a formula VDSB is equal to VB by root 3 into N naught A and B and NN A and B plus NS ASB, where this formula also you have to note down first and then this formula, second formula. Okay, think out down. Same way, when next we are finding bear capacity of the bolt, the formula is here. Bear capacity of the bolt, VDPB is equal to VNPB by VMNB, where VNPB is KB dt FUB and KB. For to find KB values, these four formulas are given. One is E by 3D naught, E by 3D naught minus 0.2 pi, FUB by FU, then 1.0 direct value. Out of this, which is small value, that you have to take for the KB. Then you have to substitute, then you have to find out the bear capacity. So shear capacity and bear capacity both are there in the page number 75 of the code book. So the formula is here FUB by root 3 into NN ANB plus NS ASB. So where NN is always 1, remember, and NS is always 0. So when NS 0, this whole term will get 0. Then VNSB is equal to 400 by root 3. What is 400? That is FUB. FUB is 400 divided by root 3 into 1. NN is 1 into A and B is just now we found out, that is 156.82. That you have to substitute, then this term will get 0. So you will get 36,260 Newton. You have to convert into kilonewton, divided by 1000 you have to do, then you will get 36.21 kilonewton. This is 36.21 kilonewton. Then you have to find out VDSB, VNSB by gamma NB. Gamma MB is 1.25. Remember 1.25. Otherwise, you can go to page number 31 of the code book, where the values is given gamma NB and 31. Page number 30 of the code book. I can show you. Here page number 30, the values is given, gamma MB, M naught, ML, everything value is given. So otherwise you can remember gamma MB is 1.25. So you will get VDSB value, then you will get 28.97 kilonewton. that now we got over with uh, shear capacity. Now we have to find out beer capacity. As I told earlier, in the 75 of the code book, VNPB is equal to 2.5 KD KB DT FUB, where you have to find out KB values. For that, we have to E by 3D naught and P by 3D naught, FE by FU and 1. So where E and P values you have to find out, that is here. E value is 1.5 D naught, 1.5 into 1827, 2.5 D, that is 2.5 into 1640 mm. You got E and P values. Or else you can directly take it as 2540 mm, 2740 mm, no need of calculations. Then KB values you have to find out. E by 3D naught, that is 27 by 3 into, if you will get 0.5. P by 3D naught minus 0.25, you will get 0.49. Then FUB by FU, that is 400 by 410, you will get 0.97. Then finally 1. So out of 4 values, the least value is 0.49, this value. So that has to be taken for the KB calculations. So the VNPB formula is 2.5 KB DT FUB, where 2.5 into KB is 0.49, and then D is 16 and T is 12, then 400 is FUB. In the code book they given FU, but you have to take it as FUB, that I told in the class also. So you will get 94,080 Newton, that is 94.08 kilonewton. Then VDPB is VNPB divided by gamma NB. Gamma NB is 1.25, you will get 75.26 kilonewton. Then after we got shear capacity and bear capacity, now we have to find out the bolt value, that is BV. Bolt value is equal to the least value of the shear capacity and bear capacity. Whatever the shear capacity value we got, that is 28.97, and bear capacity value, that is 75.26. out of this, least value is 28.97, that is the bolt value, 28.97. Then you have to find out the step 4 is number of bolts. Number of bolt is factored load divided by bolt value. Factored load is the given in the question, that is 70 kilonewton, divided by bolt value is 28.97, you will get 2.41. but 2.41 number of bolts, so we can provide 2.4 numbers. I have to convert into whole numbers, that is 3. Then you have to draw the diagram, where you can see it is very easy, 3 numbers in a row. Then in the sides they given 20 E is nothing but bolt to center dimension, the edge dimension to this dimension is E, whereas dimension from each bolt to another bolt, that is called P. So P value is 40 mm, what we calculated, and E value is 27 mm. You got it. Here also edge distance is 27 mm. Then you have to draw the total dimension also. I think we got it. Okay, we will go to the second problem, that is welded connection problem. A tie member of a truss consists of ISA 65 into 65 into 6 mm of FE 410 grade is welded to an 8 mm gusset plate. The given angle, that is 65 into 65 into 6 mm of FE 410 grade is welded to an 8 mm gusset plate. Gusset plate is 8 mm. Design a weld transmit to full strength of the member, that is. So here you can see the diagram. This has to draw in first, that ISA 65 into 65 diagram. Then the angle is given here. This is the angle ISA 65 into 65 into 6, and where it is welded on both on top and bottom, and this distance is 65, and this small thickness is 6 mm. Then this L1, this is L1 and this is L2. L1 is bigger because the top area is having some legs. So CXX value, this CXX 18.1 and this rest is 46.9. How do you got 46.9? 65 total minus 18.1 will be 46.9. This 18.1 you got from the steel table. You see here from IS steel table, page number 2, for ISA 65 into 65 into 6 mm. Wait, I will show the steel table. Okay, in the steel table you can see here ISA is page number 2, ISA 65 into 65 into 65, where 6 mm is given here. This is ISA 65 into 65 and 6 mm here. So what we need is, one is IXX value, CXX value, that is here you can see 1.81. 1.81 it is in centimeters, so you have to convert into mm, that is 18.1 mm. Same way we have to find out this sectional area also. For that you go ISA 65 into 65 into 6 and sectional area is 7.44 and the value is given in the centimeter square. We need in the mm square. For that we have to multiply with 100, that is 744 mm square. You can take the point out, that is 744 mm square. That two values you have to take from the steel table. Okay, now we got the here also you can see the 7.44 centimeter square, 744 mm square, and cxx value or czz value, that is 1.81 or 18.1 mm. That is you have to write from the top of this angle, wherever this portion comes from, there we have to take it as csx. I think we got it. If any doubt you can call me. Now we have to go first step, that is tensile capacity of the member. We have to go to the page number 32 of the code book. You can see here, I'll show here page number 32. The formula is TDG is equal to AGFY by gamma m naught. That is page number 32, and this formula TDG is equal to AGFY by gamma m naught. So that formula is AG is whatever just now we got 744 into FY is 250. Remember FY is 250 in all the problems, in all the units. FY is 250 and gamma m naught. And the first problem was gamma MB, that is 1.25. Now m naught means m0, that is 1.1. So you will get the TDG value, that is you will get in terms of Newton. You have to convert into kilonewton divided by 1000. Then second step is size of weld. There is two formula, S is equal to 3 by 4 T and S equal to T minus 1.5, where T is the thickness of the angle. The angle is given as 65 into 65 into 6, where 6 is the thickness of the angle. So that is 3 by 4 into 6, that is 4.5. Then 6 minus 1.5, 4.5. So you will get S is equal to 4.5. The least of these two values, is 4.5 mm. This is equal now. So 4.5 mm. So we can't adopt 4.5. How to adopt only whole numbers, that is 4 mm. I think we got it. Move forward. Then third step is design strength of weld. The PDW is equal to LW into TT into FU by root 3. Wait once again. Okay, that is PDW is equal to LW into TT into FU by root 3 gamma MW. This formula, it is not there in the code book. You have to remember that formula, right? How to remember that formula is, the formula is not there in the code book. The written here formula should be remembered. So where PDW is whatever TDG answer just now you got in the first step, TDG, that is I'll show you TDG value, this value, that is 169.97. that value has to be equated with PDW. That is I written equating PDW with TDG, that is 169.09 kilonewton. That is why into 10 raised to 3 you have to convert into Newton. Then LW you have to keep it as same LW. Then 0.7 into 4, that is TT value. TT, for the TT there is a formula, that is 0.7 into S. What do you mean by S? That is size of weld, just now we calculated, that is 4 mm. So S is 4 mm. So 0.7 into S is 0.7 into 4. Then 410, that is FU. FU is 410 given in the question. Then root 3, then gamma MW is 1.25. E gamma MW, M naught, then gamma MB, all the values are given in the page number 30 of the code book, 30. So we will get after simplification you get 530.24 LW, and we can calculate LW value, that is 318.89. we will get the LW value, will get this much. Then after this you have to go with the draw the figure, the initial figure 18.11 and 46.9, where top L1 and bottom L2. So from the figure we will get that how to L1, this L1 into 18.11, that is L1 into 18.11, and L2 into 46.9 is equal to L2 into 46. This formula is there whenever they will ask for two sides of weld. Whenever they will ask for three sides of the weld, the formula the method is different. I'll show in the next problem. So this is L1 into 18.11 and L2 into 46.9. So we'll get L1 in terms of L2, L1 is equal to 2.59 L2. You will get like this. So whatever the LW value we got here, that is LW is equal to L1 plus L2. Both L1 plus L2, that is length of the weld. LW is nothing but length of the weld. So L1 plus L2 is equal to LW. Wherever 3 side will come, L1 plus L2 plus L3 is equal to LW will come. Here 2 sides, so L1 plus L2 is LW. So wherever L1 is there, that is 2.5 L2. So we can substitute that is as 2.5 L2 plus L2. So we will get 3.2 2.5 L2 plus 1 L2, that is 3.59 L2 is equal to 31888. Then we will get the L2 value, that is 88.83. So L1, how to find out? We can L1 is equal to 2.59 L2, that is we got here. So that 2.59 into L2 value 80.83, that you can multiply. So L1 value got. Finally you have to write L1 values and L2 values. Here some problem is happened. Actually this is L2 and this is L1. L1 is 230.86. See properly. L2 is 88.83. Interchange you have to make L1 and L2. That is small wrong happen here. Okay, now we'll go with the third problem. As I told earlier, here 3 sides are there. So ISA 90 into 90 into 8 mm FE 410 grade when welded to a 8 mm gusset plate on all 3 sides. They mention all 3 sides. Okay, so we have to weld in the 3 sides, bottom and side, and this side, top and bottom. This diagram is given in the question. Sometimes they will not give, but you have to understand the question. So here we drawn a diagram. See here, ISA 90 into 90 into 8, and this whenever 90 comes, this distance will be 90. And why I had drawn reverse? Any idea? Because in the question you see here, where this is small and this is more, wherever more weld length is there, then wherever that portion will come legs. Remember that. So this is the leg, where this 25.1, that is CXX value, as I told in the from the steel table I'll show next later. This is LW. Here 3 sides weld is given, so we have to make some changes here. This is 25.1, then this is 90 minus 25.1, and the thickness of the angle is given 8 mm. Then bottom is L1 wherever leg will come, and top is L3 and the side one is L2. Wherever L2 comes, that is force P2 is there. Wherever L1 comes, force P3, and wherever L3 comes P3, L1 comes P1. These are the loads we have to. Then wherever loads will come now, there will be a bottom. I written 1. This will help in the later stages where you have to find out the moment about section 1. That is section here. So anyhow, we'll go to the we'll solve the problem now. Now from the IS handbook or steel table, page number 4 we have to go. Page number 4. I'll show the steel table, right? Here in the steel table, this is page number 4. This is angles. You can see this is angles. Page number 2 also angles. We got 65 to 65 here, but the more values will come in the next pages. That is IS 90 into 90 into 8 mm we want, right? This is 90 into 90 and 8 mm. This is 98 mm. Where we have got the, this is area value, that is 13.79 centimeter square. That's why I have to multiply with 100. That is 1379 millimeter square. Same way CXX value will be here, that is 2.51 centimeter or else 25.1 mm. That is what I written here. See here, that is 25.11, and the rest is 90 minus 25.11, and the value is here, that is 13.79 CXX value, AG value, that is 1379 mm square, and 6 is 2.451 centimeter and 25.1 mm. We got it. Now we'll go to the first step, that is tensile capacity of member. As I showed previously, page number 32 of the code book, TDG is equal to AG Fy by M naught. I don't explain previous problem, you got it properly. AG value, then Fy, then 1.1, you will get in subs of Newton, they have to convert into kilonewton. Then you have to go for size value, 2 values, S by 3 by 4 into T and t minus 1.5. Here t value is 8 mm, so 3 by 4 into t, that is 6 mm. 8 minus 1.5, 6.5, least is 6 mm. So adopt s is equal to 6 mm. And tt you have to find out 0.7 into s, 0.7 into 6, that is 4.2 mm. Then you have to go for design strength of the weld, where PdW is equal to LW into TT into FOU by root 3 gamma MW. This formula has to be remembered. This is not there in the code book. Remember properly. So where PdW is equal to TDG, that is equating. Next step is equating PdW to TDG, and whatever the TDG value we got, that is 313.41 kilonewton. 313.41 kilonewton, that I have to convert into Newton into 10 raised to 3. LW is LW, 4.2 is TT value just now we calculated, and 410 is FU value, then root 3 into 1.25 is gamma MW. So we will get 795.36 LW. Take it as a star equation. Star will help in the next later stages. Now we got the LW value as 384 mm. After simplification of this one, we got LW is 394 mm. So LW is equal to L1 plus L2 plus L3. Here 3 sides are there, that is why 3.4 mm. And L2 is 90 mm. How we got that 90 mm? I will show you the diagram. Here this is L2, right? The height of this angle is 90 mm and this will be 90 mm. That is why always whenever 3 side comes, this is will be L2 and the L2 value will be the angle dimension, that is 90 mm. Okay, here L2 is 90 mm. Now taking moment about section 1.1, that is, remember the section 1.1 I shown in the diagram. You can see the diagram where P1 into P2. So here first in the left side, that is P into 25.1. P is force. P into 25.1 is nothing but the CXX value or CZZ value, that is 25.1 is equal to P1 into 0. Directly you can remember like that. P1 into 0 plus P2 into 90 by 2. That is whatever the L2 value is here, 90 90 by 2. That is P2 into 90 by 2, and P3 into 90. Whatever the value is, P3 into 90. There is a that has to be calculated in by seeing the diagram, but you can simply remember like this: P1 into 0, P2 into 90 by 2, and P3 into 90. Here P into CXX value, that is 25.1. So we will get P is equal to TDG is equal to, this is how to equating P into P is equal to TDG. TDG value whatever we got now, that initially we got, that is 313.41 into 10 raised to 3. So that into 25.1, that is 25.1 is equal to P1 into 0, 0, P2 into 90 by 2, and P3 into 90. So wherever the P value is there now, that is 75. This value you got from the star equation, as I told here. This is the star equation here. This equation is written again here, that is P is equal to 795.36 LW, and that's why we want to find out the P2 and P3. Wherever P2 comes, here L2, P3 comes L3. This equation you have to modify. So after that you have to substitute in these equations, this equation here. So 313.400 to 3 into 25.1 is equal to this. Wherever P2 comes, substitute 795.36 to L2 into 90 by 2, and P3 is 795.36 L3 into 90. So after this to go for the simplification, finally we will get here L2 values is known. What is L2 value? That is 90 mm. So I have to substitute L2 value also. You will get L3 is equal to 64.89. So we got L3 and L2 also we know. So how to find it now? L1 is left. So total we know L1 plus L3 is equal to 394 mm. We got it initially. So L1 is 394 minus L2 minus L3. So 394 minus L3 is L2 is 90, L3 is 64.89 we got, and L1 is got. So finally you have to write L1, L2, L3. This you have to get it. Okay. Anyhow, module 2, these 3 problems if you study, you will get 30 marks exam. So I think this is the easy chance where only page number 75 of the code book, page number 30 and small and steel table 2 and 4 are required. So it is very easy, and study well. All the best.